All right, here we go, Math 8. We got lesson 10-2, correlation with best lines of fit. So we're going to take the best lines of fit that we were doing on the last lesson and then just look at it and be able to do a little bit more with it. So we're going to be looking at a couple of new things. We're going to be looking at positive and negative correlation. All this means is what is the general relationship between our x and y values in the scatter plot. So if the x and the y values, as you're going from left to right, are both increasing, then you have a positive correlation. So basically, it's like a positive slope. It goes from left to right, goes up. Just like it's the same thing, positive correlation just means it's going up from left to right. And just like a negative slope means that as the x is increasing, the y is decreasing, if you've got a graph that is going downhill from left to right, that's going to be a negative correlation. It doesn't mean that's a bad correlation. It just means that as one of the variables is increasing, the other one's doing the opposite and it's decreasing. So positive, negative correlation. The other thing we're going to look for is outliers. Now, for right now, we don't have a true definition of what an outlier is. There's some formulas that we can do to find out what an outlier is. You'll do that later on in high school math. For right now, we're going to just say outliers are points on our scatter plot that don't really fit the rest of the data. They're either way too big or way too small for our data. Now, outliers, sometimes they're just mistakes. While you're taking data, you make a mistake. Maybe you switch the x and y or something. And so you can tell one of your points looks really different from all the other points. So we might call that an outlier. And then sometimes things that are unlikely just happen. And it's unlikely, but it still happened. So we would just call that an outlier. It doesn't look like the rest of the data, but it is a piece of data. All right, so as we go through the rest of this, we're going to be looking for positive and negative correlation and outliers. Okay, so I'm using the same example here just because I was lazy. So here's the same example as we did on the last set of notes. We talked about finding that best line of fit. Remember, we said we didn't want to go above the data, we didn't want to go below the data. We want to go through the center of the data, somewhere slightly through that middle. All right, and we said, I don't know, I think we said it looks something like this-ish. How about this line? Does that look good? That's too high, but whatever. So there's a best line of fit. I'd probably want it a little bit lower, and it's starting to bother me right now, but whatever. That's what a best line of fit looks like. It looks like the best middle for your data. And I did this today with my kids in class, but one of the things you can do before you put your ruler down, you can just kind of eyeball where you want your middle to be and just kind of like make a mark like that. And then when you pull out your ruler, you can go, oh, there's where I was going to make the middle. So there's my middle. There it is. And then that looks like a better middle, right? So that's one thing you can do as you're making your best lines of fit. Remember, there's a lot of grace in these best lines of fit. We're just trying to get a general idea of where the correlation between these two is going. All right, so we found the best line of fit on the last one. Remember, we looked for the y-intercept first, and then we looked for another point just by kind of like estimating, oh, this is x is 9, so what's y? Oh, it's around 40 or something like that. We found another point, and we could find the slope between those 2 points. And that's what we did on the last lesson. We're not going to do it again. All right, what we're going to do today is we're going to say, okay, we're going to pretend like whatever line we just made was this line right here. And we're going to start using the line to make predictions. So remember, this was the target practice one, where we were comparing the distance from the target and the percentage of the shots that are going to hit. There's some children's archery camp, because that's safe. Give children bows and arrows. So we got children's archery camp. They move farther away from the target and they hit the target less. That makes super sense. So this was the equation for it. X is the distance from the target and Y is the percentage of the target hits. All right, so we're going to use our equation to predict the percentage of shots that would be made at 15 feet. That is an X value. We want to know what is our line telling us at 15 feet? What's the percentage going to be? Well, it looks like it should turn out to be around 20% or something like that, but we're going to mathematically find out. Oh, I got to get my calculator. All right, got my calculator. We're good to go. All right, so 15 feet, that is an x value. So I'm going to use this equation and plug in for x, and that's going to give me my y value, the percentage, because we're trying to predict the percentage. So that's what lines of best fit can be used for, is for making predictions of things that haven't happened yet. So we're going to say y equals negative 4.8. X is going to be 15 plus 88. All right, let's see what we got. So we're going to do 4.8 times 15. 72. All right, so this is negative 72 because it's a negative times a positive. I get negative 72 plus 88. 88 minus 72 is 16. So what's the answer to our question? We predict that we would hit the target 16% of the time. Well, we wouldn't, the kids would. That when we're 15 feet away, we're going to hit it 16% of the time. So the answer is 16% target hits. And that was pretty close to our guess over here, right? We were guessing like around 20. Actually, now that you look at it, you can tell it's going to be below 20. So yeah, we're pretty close to our guess right there. So we can use our equation to predict things that haven't happened. Now we're going to use our equation to predict the distance from the target you would need to get 50% shots. So what if you wanted to make sure the kids are making 50% of their shots, half of their shots? How far away would you put these kids? So 50% of our shots would be here. There's 50%. So if we go over to our line, what's the x value going to be? Well, I'm going to say that it's going to be somewhere around, 7 feet away. That's what it looks like it's going to be. Let's see by plugging it in. Now we're looking for the distance. That's the x value. We're trying to find the x value. And 50%, that's the y value. So I'm going to plug 50 into y and then solve for x. So let's take our equation. Going to plug in 50 for y equals negative 4.8 x plus 88. All right, using inverse operations, I will now subtract 88 from both sides. $50 minus 88 is negative 38. And using inverse operations, I will now divide by negative 4.8, because this is negative 4.8 times x. So I'm going to do the inverse of multiplying and divide by negative 4.8. All right, let's see what we get. 38 divided by 4.8. I already know the answer is going to be positive, so I didn't worry about plugging negatives into the calculator. A negative divided by a negative is positive. So a lot of times with my calculator, I won't plug in negatives because I already know what the answer is going to be. It's going to be a positive number. So I'm not going to waste my time plugging in negatives. And my answer is, 7.9. Remember we predicted it is going to be about 7? Yeah, 7.9. We're around there. Not too bad. So the answer would be 7.9 feet. That's how far away we should stand or have the kids stand to get 50% of their shots made. All right? Is it a positive or negative correlation? Well, as we go along, as the x increases, is the y also going up? No, as x increases, y is going down. And that makes sense because the farther away we get, the less shots we're going to make. So this is not a positive correlation, it's a negative correlation. The correlation is, as we move away from the target, we make less shots. The number of shots we make decreases. So this is a negative correlation. All right, so are there any outliers? These points aren't super tightly grouped. They're pretty tightly grouped. There's some that are a little bit more than the line. This one's kind of far away from the line. But none of them are super crazy far away from the line. So I wouldn't consider any of those outliers. So we're going to say no. What would I consider an outlier? Okay, let's say that we had some kid out there, he was 15 feet away, and he made 100% of his shots. That would be that data point right there. That is way off of all the other data points. We would consider that an outlier. Maybe he just got lucky. So maybe it actually happened. This kid was 15 feet away. He's just plinking away, pink, 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 hitting it. Maybe he's a savant. I don't know. That would be an outlier. That is a crazy percentage. What if we had another kid who was 1 foot away and only made 2% of his shots? That would be a point way over here. 1 foot away, 2% of our shots. That would be an outlier. That's way off of all of our other data. We would consider those outliers. When we're considering outliers, we don't really look at those for the best line of fit. We don't try to move our line to include those outliers. When we're doing our best line of fit, we're only looking at the majority of our data that is packed together. The outliers are not going to affect where we put our line of fit. All right. Next, we got some practice. So if you're doing this on your own, go ahead and try to you draw your best line of fit. We already have an equation. Try to answer these questions based off of this graph over here that we've already done. This is the equation for the best line of fit. You can draw your own in there and then answer those questions. So if you're doing this on your own, I'll just pause right here. You can pause the playback, the video, whatever. Are you done it? All right, because here I go. Okay, so again, remember I said I was going to kind of eyeball where the line is. I want the line, I think, right about, I don't know, here-ish. All right, now that I've got that, I'm going to pull out my ruler. I know where I want my line to be. Sometimes when you cover everything up with your ruler, it's hard to see where you wanted your line in the first place. So there we go. Oh, that looks pretty good. That's going through the middle pretty well. And it's matching this up over here pretty well. We said 0.4 for the y-intercept. That's a little bit lower, but that's fine. And 1.05 for the slope. Sounds great. Is there a positive or negative correlation? As the x is increasing, is the y going up as well? Yes, it is. So this would be a positive correlation. Number 2, circle any points that are outliers. We definitely have 2 outliers. This one is way too big. This one is way too small, comparing our y values. So we would consider those outliers. You can have 1 outlier. You can have 3 or 4 outliers. They can be above the line. They can be below the line. It's just anything that doesn't match the majority of, oh gosh, I got the hiccups. The majority of your data. Almost there. Oh gosh, it's killing me. All right, now we're going to use our best line of fit to predict the y value when the x value is 10. So we're going to use this. We're going to plug in 10 for the y value, or the x value, to find the y value. I'm going to hold my breath. All right, I think I'm better. So we get y equals 105, 1.05 times 10 is 10.5 plus 0.4. So our prediction would be when the x value is 10, we would expect the y value to be 10.9. Gosh. Let's hurry this up so I can get a drink of water here. Okay, so use your line of best fit to predict the x value when the y value is 15. Okay, so I'm going to plug 15 in for y. Okay, so we're going to use inverse operations. I'm going to subtract 0.4 from both sides. 15 minus 0.4 will be 14.6. Ah, wrong color. Hiccups. All right, and now the last operation I would do, this is 1.05 times x, so the inverse operation would be to divide by 1.05. All right, so 14.6 divided by 1.05. Looks like it's going to be 13.9. So the x value, about 13.9. The end. I'm going to go get a drink of water and do the next lesson after that. All right. Math hard. See you guys later. Bye-bye.